Example 3 says we have a twice differentiable function f defined for all real values. So this twice differentiable is important in that it tells us that f and f prime are both smooth and continuous. And so we've been given some values of f, given some x coordinates -2, -1, 1, and 3. We've been given values of f and f prime, and we've also been given the sign of the f and f prime in between those coordinates. So for A, it says find the x-coordinate of each relative minimum of f on the interval. To do that, we're just going to do a slope chart. So if I draw my slope chart out here, I've got my slope chart. I'm looking for where f prime is equal to 0. So I have a 0 here at -1, a 0 here at +1. So I'm going to show my slope 0. So this is my x, f prime, and then I just need to test for slope, positive or negative slope to determine the shape of the function. So I'm going to look at my slopes. To the left of -1, it's negative, so it's going to go down like this. It's going to go to the horizontal tangent, negative again, so it's going to keep on going down. 0 slope, and then positive, so it means it's going to go up. So when I look at this function, I can see that it just kind of goes like this and like that. So I have a relative minimum at x equals 1. Okay, so it's going to go like something like that. Okay, so I have a relative minimum at x equals 1. So at x equals 1, we have a relative minimum, and the slope chart justifies this. Okay, so for part B, it says, explain why there must be a c value on the interval -1 to 1, where f double prime of c equals 0. Well, this relates to the mean value theorem. So if I take a look at f double prime of c, really what that means is it's the slope of the f prime function. Okay, so since f prime is smooth and continuous, so I'm just going to write this here, f double prime of x is equal to the slope of f prime. And since it's smooth and continuous, we can say that the average slope of f prime between -1 and 0, so if I take a look at the between -1 and +1, the average slope between those 2 points is going to be 0. So the rise is 0 over run is 0. So slope of f prime, and so we're going to say that the average slope of f prime is going to be the rise, 0 minus 0, over the run of 1 minus -1. Basically, we have a slope of 0. Okay, well, if the average slope of f prime is equal to 0, then, which relates to the f double prime, since f prime is smooth and continuous, we can apply the mean value theorem and say that the slope of the instantaneous slope, or f double prime at c, must exist where it's equal to 0. So first of all, I'm going to state f prime is smooth and continuous. Okay, so that's an important condition. So therefore, by the mean value theorem, we can say that the derivative, or the instantaneous slope, is going to equal the average slope of 0, and it must occur in the interval from -1 to 1. So c must be, in fact, I'm going to write it in here. This is the average and c must be in that interval. Okay, this is the mean value theorem. Okay, so part C then, it says the function h is defined by h of x equals ln f of x. Find the derivative at x equals 3. This problem involves differentiating notation. So I'm going to take the notation h of x, and I need to differentiate this notation. So h prime is equal to 1 over f of x times the chain rule, so that's going to be f prime of x. Okay, so what I need then is, if I want h prime at 3, it's going to be 1 over the f value at 3. Okay, well, I have the f value at 3, so when x is 3, f of x is 7. Well, I have that, and it's times the f prime value at 3, which I have as well, because it tells me the second value here is f prime at x equals 3. Well, I have that as well, so once I know those parts, I can just plug them in. So I get 1 over 7 times 1/2. Okay, that's 7 down here. Oops. This 1/2 comes from here, and the 7 is the blue part here. That comes from f of 3. Evaluating that expression, I end up with 1 over 14. So f prime at 3 is equal to 1 over 14.